Today we'll be covering How Could They Win, which is a paper that recently got accepted into KaiPlay. This talk is an extended version where I included some things that didn't actually get to be included in the paper. Now, because I'm talking about esports and how we can use win condition to enhance esports narratives, I first want to start with why I'm talking about esports and who cares. Esports is a really rapidly growing market. Right? It attracts over 500 million viewers annually, which makes it one of the fastest growing sectors on the gaming industry. And then if you take the gaming side of it out of the equation, it's also one of the fastest growing streaming markets in general, one of the fastest growing. And you can find this information on these three market reports. And of course, that means that it has vast financial interest because it's a big market and growing. Not many other markets can say that. But it also has quite a lot of academic interest, which is really the thing that I care about. And in particular, I want to draw your attention to the machine learning literature, which is my area. And if you look at the machine learning literature, no other topic is more predominant than win prediction. It's a really well studied, really well understood and polished topic of research. And when I say win prediction in terms of esports, it's where we take some game state data, so data about the state of the game, the state in which the game is in. We put it through some form of a machine learning model. It will go through this sort of black box magic sort of bit, and it will spit out a number. And then we present this number, and the number is how likely is Team 1 to win. So certainly in the case of Dota 2, which is the esport of choice, this is actually the graph that is available in Dota 2. So anyone watching the game can actually just open that and see the win prediction graph. And the way that it works is anything when the line is above the middle, Team 1 is more likely to win. When the line is below the middle, Team 2 is more likely to win. So despite it being really well understood and actually bridge the gap from academia to industry, where things like Dota 2 already have win prediction graphs built in, there are a few problems or a few what we call dilemmas to do with win prediction. Especially when you're thinking about win prediction in terms of audience experience. So the first thing is the accuracy dilemma. So this is a really well-known problem to do with how win prediction graphs work. So the accuracy dilemma is to do with how the model performs. So in one hand, if you have a model that's too inaccurate, that's too bad at predicting, that hopefully I don't need to explain why that's not very useful because it's bad at predicting, it's bad at doing its job. On the other hand, if the model is too accurate, that's also bad. And that's a bit more nuanced. So it's bad because a lot of the excitement, a lot of the positive attributes that come towards watching esports content come from the suspense, comes from the emotional arousal of the narrative, of not knowing what's happened next. So if you have a model that at the start of the game can always get exactly right who is going to win the game, then what's even the point of playing the game? Because the model is always right, we can just run it through the model and that can be the whole competition. And that really detracts from the audience experience. So that's the accuracy dilemma. You want to have a model that's good, that can predict things, that is reliable and doesn't affect trust, but also that isn't that good, that doesn't detract from the experience. The second one is the usability dilemma. And this is more to do with the way that the models are presented and sold to audiences and what we expect them to do and what they actually do. So here, I'll continue using the example from Dota 2. You can see at the bottom here, those are the timestamps. So you can see at minute 0, at the start of the game, starts at 50-50. Both teams are equally likely to win. And then around this timestamp, Team 1 is very likely to win, and it starts to taper down until you reach about here, where something happens. What this something is doesn't matter right now, but something happens, and then suddenly Team 2 is more likely to win. So then the question is the model right? But answering that question is not exactly easy, because like, what does that even mean? Is the model right? Is the model right down here? Or was the model wrong here then? Because there it was predicting team 1, and now it's predicting team 2. And this is where the dilemma comes in, because this model isn't actually predicting the future. This isn't actually a predictive model. A more accurate way of describing the model is that it summarizes the game. It gives you right now who is winning, which is a different question to who will win the game. But of course, if you say this is a win prediction, as a user, you expect it to predict the future, expect it to be forward-facing, when here it is not. And of course, if we accept the fact that this is a summary, this is a model that summarizes who is winning, and hopefully we can all agree that that's what's doing, then something else should come to mind that's heavily involved in building narratives, they're heavily involved in esports broadcast, which is the commentator. So I actually spoke to commentators whose job is to summarize the game and build exciting narratives to enhance the audience experience. And I asked them, amongst many other things, but specifically, do you ever use it? It being the win prediction graphs. And I have 2 quotes for you that will hopefully summarize their answers. So one of them said, it's a bit of a meme graph. We only use it for desperate and only to make fun of it. Not great. The other one said, never, it's not useful, and there's always something better to talk about. And then he paused for a moment and added, like what I had for breakfast. Not ideal, right? You don't want, and if you think about it, these models take months to train. There's a lot of data needs to go through it. You don't want to work for that long to then have the broadcasters who are supposedly to use these sort of models to say that about it. That's not ideal. So then started my 4-year journey of defining what I propose as a win condition model, which is a variation of how win prediction works. So a typical win prediction, the things that already exist, you can express it as a function of the game state to predict the winner. The win condition flips this around. It becomes a function of the winner to predict the game state. And just to explain that in a more visual way, we have a diagram at the bottom where we have state in one side, S, the black box of magic in the middle, that's the model, and then winner in one side. So in both cases, the win prediction and the win condition, the diagram is the same. But on win prediction, data will flow from the state to the winner. So you go from left to right. That's your input, that's your output. On win condition, data will flow from right to left. We start with the winner, and we say, what is the game going to look like when they win? And this is how narratives are formed. This is how broadcasters talk about it. And I know that because we did some qualitative content analysis to define what are the narrative features, looking at actual broadcasts, looking at actual narratives that exist. So we did some qualitative content analysis to define what is state. And this is the sort of outcome of this process where we have the win condition system described in here. So we have lineup and winner star as our starting inputs. They go through neural network 1, which will then predict the duration of the game. Then these 3 variables, the lineup, the winner star, and the predicted duration go through neural network 2, which is a separate model, which will then predict the amount of kills that the game will have. And then together, these 4 variables are the state given the winner, which then leads me to what exactly is winner star, which is this thing that I mentioned. So that's an exploration variable, right? We don't know who will win the game, so we can't run this. Or we can, but we don't know which is right. We run it twice. We run it once for team 1 will win, once for team 2 will win. Which, of course, it's exactly how narratives are built, because the broadcasters don't know who will win, and if they did, what would be the point of playing the game? So we run through the system twice, and we present it to them, and we can present it in many ways. We can say, team 1 is predicted to win at approximately 20 minutes with 25 to 9 kills. And then completely separate from that, and independent from that, we can say team 2 is predicted to win at that time with that many kills. There is no comment on which scenario is more likely. This is a narrative building exercise. This is a tool for the broadcaster. So they are read independently. We don't know which is more likely, but if team 1 wins, that's what's going to happen. If team 2 wins, that's what's going to happen. And we can present that in a more explorative way, even further, so we can do something like that. So this is for team 1 on the same game. We can see at the 10 minutes mark, so if the game lasts for 10 minutes, that is the score. If the game lasts for 20 minutes, which is what Neural Network 1 predicts, which is why it's highlighted, that will be the score. And as you can see, this is 9 to 25, which is exactly what you had the previous slide. And you can do that for all the timestamps, and of course you can do that for both teams. And you present that, and the broadcaster can build the narratives. And because these tools are built already with their existing narratives, we're not trying to force them to use, hey, here is a model that I've developed. Use it. Make it fit. No. I take, what do you do? What do you talk about? How can we design things that make it fit? And when we look at how they do it, well, they talk about time. They talk about kills. They talk about, given this lineup, this team, they have to kill that character to win. They have to dominate the early games, so therefore they need like a kill advantage at the start. There's a lot of narratives that they can build by looking at these graphs. And yes, they're not necessarily the more intuitive, but remember the broadcasters are experts. Right? They are professional broadcasters. Their job relies on absorbing data from the game and building narratives. This is a tool to allow them to do that further with some machine learning attached to it. And then in terms of what happens next with this project, so the idea is to perform some user evaluation. So that is alongside the broadcasters and audiences, evaluate what their needs are further now that we have a system for win condition, to iteratively design the visualization system. How can we make that graph more accessible? How can we make getting to that graph more accessible? How can we make it so it fits with the pipeline of producing esport content? Because the broadcasters, they have a lot to do, right? They have to understand what the game is. They have to create narratives, and they have to deliver these narratives in an engaging way, in a useful way, catering to all of the needs, all the various needs of the audiences. So we want to work with them to make that job easier. So we're going to iteratively design this visualization to make sure that they can actually cope with the cognitive load of doing it, cope with the narrative needs associated with it, and then implement it in an actual tournament, as we've done with previous projects in the past on my PhD. Actually put that in, say, ESL, actually put that in maybe a local tournament, maybe a university tournament, working with them to then evaluate the impact on the audience experience. Because everything we've done so far is the starting step. Took 4 years to get to here, but we're still on the starting step, such is the nature of research, I guess. But yes, this is our first step in a long journey of really making sure that the things that we're designing, the things that we're presenting, are not less interesting than whatever the broadcaster had for breakfast that morning. We'll get there someday. Woo! Okay, so like I said, this is an extended version of a paper published in KaiPlay. So here is some of the bibliography that I mentioned. I preserved the numbering from the paper. The paper is the same title as the talk, by the way, so you can find it. Here's some others. But that is everything I have for today. So thank you very much.
Right, okay. So we'll have questions. So I'm going to throw this at you. I'm so sorry if I hit someone.
Okay, and it's on. First of all, great talk. Just a question on, you said we run it once or twice. Why not run it hundreds of times, right? Because sports are stochastic. And what you really want is a distribution of possible outcomes and a number of possible ways that win or loss could be achieved.
Yeah, no, that's exactly what the graph does. So we run Neural Network 1 only ever produces the same outcome with the same lineup and the same winner, right? Because that's predicting the duration. So what's the likely duration? But Neural Network 2 takes duration as an input. And what we do to generate these graphs is we say, well, let's assume that team 1 will win and the game will take 10 minutes. The score will be that. If team 2 wins and the duration is 20 minutes, the score will be that, and then so on and so forth. So we populate. And we actually have something I didn't include, which is we actually use a standard win prediction, a more traditional one, and we spread out and build a heat map. So for every timestamp, for every kill sort of spread, how likely are each team to win. That's really hard to read, and this is something I definitely want to improve, which is why it's not on the slide. But it's the idea of like, how can we make all of the possible what-if questions available, but also in a digestible way that the broadcasters can actually use.
So you might sort of focus on particular key events that are likely to happen in particular
exactly.
scenarios. Yeah, great, super. I think there are other ones.
Oh, gosh. Okay, another question. Oh, I saw your hand go first. So.
Great talk. How do you? Obviously you had the pretty ill reception of these things with the commentary team, and you're hoping to provide something that suits their needs better. Quite often with these kind of like expert, here's a new tool vibes, you get like when it does something clever, they kind of like, yeah, whatever, and when it does something bad, they're like, this is awful, it never works, even though like you can quantitatively show that it does work better than they're assuming.
Yeah.
So how do you battle that? Yeah.
Well, the short answer is with great difficulty. You're absolutely right. That's exactly what typically the response we get from, especially from players. Like professional players really hate these sort of things. They always assume they know better. And to be fair to them, a lot of the time they do. It's esports are complex and hard. But I think the solution to this problem is doing exactly that. Is like, if you just go and you make a tool and you say, here's a tool, use it, that there is going to be resistance because you're designing a tool and you're trying to sort of shoehorn your tool into the way that they already do things, where if you do things more the way that this is designed, we really do understand what are the needs, what are the things we can actually do to fit the things that you already do, to enhance the things you already do, and then they're much more receptive. So like I said, I've been interviewing broadcasters, and the reception to win prediction is, no, hate it, awful. The reception to, at the end, when, debriefing and explaining what this is for, and usually we're met with excitement. It's like, if this works, and this is constructive, and you can actually make it, highlight things that I want to talk about, so I don't have to make my narrative based on what you want, then yeah, I'll definitely use that. That sounds great. And I think that's the answer is, right, we do that for software. We do that for policy making. We do that for everything else. Why do we not do that for these sort of models? That, because getting data is hard, we design the model in the way that we think it has to be, and then the user has to adapt. That's typically the answer that sort of machine learning solutions tend to end up because of the limitation. Well, I say let's try not to, if we can, which, isn't necessarily going to work, but I'm at least going to try.
Do you have a question? Right. Yes. I'm sorry.
That's right. No, that's much safer. No, it's a bit of a follow-on, really, which is surely part of the point of these sorts of tools is, as you say, not to be accurate. That you want people to make fun of them. You want them to make silly, concrete suggestions because that actually improves the. This is a broadcast. This is entertainment. Mm-hmm. And it would be dead boring if they. You're being much more specific in terms of they're going to win with 43 kills to 9, and it's more opportunities for the commentator to take the mickey out of your system, which is a good thing.
Yes.
Comment.
Sure. As a narrative tool, if the tool is bad, and the commentators can actually say why it's bad, and actually build narratives, then that definitely works. The problem is if you take the second quote of like, I always have something better to talk about. They don't see the value in doing that, so they don't use it. So, I take your point, yes, if it's bad and they make fun of it,